Hello, everyone. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Annie, and I'm a CNCF ambassador as well as a senior product marketing manager at Camunda, and I will be your host tonight. So, every week we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they will break things, and they will answer all of your questions. So, join us every Wednesday to watch live. So this week we have Nick here with us to talk about Kubernetes-native pipelines for stateful applications. And another exciting thing happening in the cloud native sphere is that KubeCon and Cloud Native Con North America early bird registration deadline is today. So get your tickets fast if you want the early bird rate. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of your fellow participants as well as presenters. So I'll hand it over to Nick to kick off today's presentation.
Thank you. Thank you and welcome everyone. My name is Nick. I'm a developer advocate with Ondat, and I've been working with Kubernetes approximately for the last 5-6 years. And the topic for today is going to be focused around building native pipelines within Kubernetes for stateful applications. So the idea is really to focus on the developer experience, from a real use case application, and we're going to start with there into from developing the application and moving to from your local laptop to a Kubernetes production cluster. So maybe I can start sharing my screen and we can get started. Okay, so this is what we are going to build today. Hopefully 45 minutes, 1 hour will be enough. But here is the idea. When I started to work with Kubernetes, I was kind of confused. How can I start developing my application and make it a good application for Kubernetes? What kind of Kubernetes concept I should use? What kind of tools I should use to manage the lifecycle of my application from my local laptop to the staging cluster to the production cluster? And what are the key concepts when it comes to also deploying and building stateful application? So what is important there is let's start by defining what is a stateful application. So stateful application means that one or several components of that application are stateful, or in other words, they store some data to disk. So it can be a database, can be a caching solution, basically anything you need that needs to persist between user or for usage, or just to present some sort of data to maybe a front end. So you will need some sort of database. So the idea is, let's start by developing that application. So it's already there, but we're going to start with the code and then go into how do we make this application inside a container, like using Dockerfile, things like that. And then from Docker, how can we move into a more highly available environment like Kubernetes? So this is the idea. We're going to start with an app that I call the Marvel app. So just to give you an idea, I think it's still open there. It's basically this app where it's showing a bunch of characters on the screen from the Marvel APIs, right? So it's basically like I'm looking for the image, and then I'm showing the name of the character, and then the comic books where the character has appeared. And then I've 1, 2, 3, 4, 5, I've got 6 cards with this information. That's basically what the application does. So it's a 2 microservice-based application where the first part is essentially what you've seen. So the front end, which is using Python Flask, and the back end is a MongoDB database where all the semi-structured data, so all the JSON information from the Marvel API is stored. And the idea to build this application in Kubernetes to also show you what kind of basic, first-class concept from Kubernetes you can use, I've decided to build this application in the following way. So we're going to build a 3-node MongoDB inside Kubernetes, which is basically our stateful application. We're going to have a couple of pods deployed as a deployment that will be basically the front-end application. And then we need to populate that database with the Marvel information. So for this, I've created a Kubernetes job, because I mean, there's different solution on how to do that, but the job, like just to show off how it's working, it's a good solution, because the job is going to be running until it succeeds. So meaning that it's going to try to connect to the Marvel APIs, get the information, store it to the database until it succeeds. So basically until at least until the cluster, the MongoDB cluster is available. Once the MongoDB cluster is available, the job will succeed and populate the database. And then as a result, the application will start working. That's the idea of running that application in Kubernetes. But for this, we need a proper lifecycle. So I'm going to start by showing you what tool I can use to facilitate the development of this application on your laptop. So the expectation here is that as I save code into my application, I can do things as automatically building my Marvel container or my job container, for example, as soon as I change some of the code without doing anything else. Sort of, just monitoring the file system. When a file that I monitor is changed, then ideally what I want is the system I'm using or the tool I'm using to build the container and basically deploy it into my local Kubernetes cluster testing environment on my particular laptop. So for this, I'm going to be using K3D, which is just a wrapper around K3S. So, but you can think about it as just as K3S. So K3S, which is the Rancher sort of very lightweight Kubernetes distribution, you can basically install anywhere, a simple binary. So this is basically there on the top. This would be the pipeline, right? So you start, committing code, not necessarily committing, but just saving code to your laptop. Of course, at some point you want to commit it to Git for further usage, maybe when you want to deploy to production. But for the moment, what I want first is to have the right developer experience on my laptop. So I want to save code. Then when I save code, the Docker images are built, and eventually also they are saved into the remote repository, a remote container repository like Docker Hub there. And then once the Docker image has been built, I want to use some sort of tooling to build the Kubernetes manifests and then deploy it into my local cluster. But remember, we also have a stateful application component, which is our MongoDB. And this is where you may want to add a couple of extra features so that it represents the end, kind of the end environment, the production environment you may want to test earlier in the code lifecycle. So basically, if you want to run smoke test, including some of the infrastructure components that we will be deployed in production, you can do it on your laptop because it's just Kubernetes in the end, right? It's just software. So for MongoDB, we're going to be using OnDat, which is a solution that allows you to use local storage of your Kubernetes nodes and aggregate this as a pool of consumable storage for your persistent volumes. And on top of this, add specific features such as replication, encryption, all those kind of premium features you would want to have in production. So by enabling this on your local cluster, you also have an idea of how your application will behave in production. But again, the solution is Kubernetes-native, meaning that it's just using storage class, YAML, so you can control it as part of the manifest generation, on your local laptop using Customize or Helm or whatever. So for today, the tools we're going to be using for the local, let's say, laptop development, we're going to be using, so of course, Git. We're going to be using the local, Docker that is running on your laptop. We're going to be using customize. We're going to be using on that as well. And Scaffold that you can see on the top here, actually the documentation is just there. It's really a nice tool. It's also open source, part of the ecosystem. It's a command line tool that facilitates continuous development for Kubernetes native application. So basically it handles multiple phases, in the lifecycle of your application. So this is Scaffold that is going to help automate the building of the container, the deployment of the container. So building can use Docker, can use to build here, for example, we see what is supported. So you can use Docker, like Dockerfile. You can use also cloud native build packs. You can use custom scripts and so on. So this is for the build phase. We're going to be using our local Docker socket. And when it comes to deploying, so again, this is for our local laptop-based Kubernetes cluster, you can use kubectl, Helm, Customize, or Docker. So we're going to be using Customize because Customize helps you decorate your base manifest to match a particular environment. So in our case, I'm going to have a dev overlay that I'm going to be using to deploy and to configure my manifest on my dev environment. And I will also have a prod overlay that is going to be used to deploy in the production cluster. But in the production cluster, we won't be using directly Scaffold or Customize directly to deploy it. We're going to be using Tekton and Flux, right? But this is the second part. So those are the tools for the local cluster deployment. Now, the second step as a developer, once you have it on your cluster, once the code has been committed to Git and your pull request has been validated by your peers, then it comes, it's about time to deploy either, maybe not in production, but let's say our production, which is probably like the development or the testing or staging area, like the remote Kubernetes cluster that is going to be used for that. So in our case, it's going to be GKE. And the idea is we're going to be using, again, a Kubernetes native way of doing things. So we're going to be triggering a pipeline, which is going to be doing the same kind of things as Scaffold. So the idea is we need to build the container, we need to build the manifest using Customize, and then we need to deploy those manifests with the right images into our staging/production cluster. Okay, so how are we going to do this? So we're going to be using Tekton, and Tekton, for those who are not familiar with the solution, it's also part of the CNCF ecosystem. It's a Kubernetes native pipeline software, meaning that every task you're going to be creating within Tekton correspond to a pod or a container. So an action or a command that is run into a container. And when you have multiple tasks to run as part of your pipeline, those tasks will be sequentially executed by your Tekton solution within Kubernetes as multiple containers. So the whole solution, the pipeline itself, is completely running in Kubernetes. So again, the idea is to produce the right images. So this time we're not going to be using Docker because we are running inside Kubernetes. The pipeline is using Kubernetes. It's not a good idea to mount the Docker sockets in production, right? That's bad from a security perspective. So a typical way to build container in Kubernetes, there are several of them for sure, but Kaneko, which is basically building container without using the Docker socket, is a good solution to do so. So we're going to have a task within Tekton where the goal is going to be build the container with Kaneko. We're going to have a second task, which is going to be using Customize to generate the manifests as well, that we're going to push into a particular repository. So this is exactly that particular GitHub repository. There, I have a directory which is called target, and the manifests I've tested multiple times. So it should be working. This is basically the result. What we should see in the end is just when we will be running it live, we will see a different image digest here. And the last part, once we have our manifests that are deployed into this repository, so we will have, of course, the image also is going to be picked up by Docker Hub by using Flux, right? So the application manifests are going to be deployed into the repository I've just shown you, and then Flux, which is a GitOps solution, is going to monitor that repository, monitor for changes on that repository, and reconcile. And like any GitOps solution, the goal is to reconcile the states of the cluster with the intent, which is stored in Git. So our intent is to deploy the manifests that are stored where I just showed you before. And the state of the cluster that needs to be reconciled, well, it's deploy the manifest that, or the new manifest, or the new object that corresponds to the manifest that have been changed on the Git repository. So as soon as the container image will change, we will have our front-end container that will be replaced. I won't change like the MongoDB portion because it's a bit longer to deploy, but the application is already deployed in the cluster. So what we will do is do some changes to the application and show that, trigger the pipeline that will update the image digest into the application manifest repository. And as a result, Flux will see that change and will replace the front end container with the new code, right? So the first step is really to change some of the code on the laptop, show you the developer experience with Scaffold, check the result on the local cluster. Then we're going to be triggering, let's say, the staging/production pipeline, and we will double check that this time it's our GitOps pipeline will pick it up and deploy this into the production cluster. So if I don't know if there are still, is there any question at this stage before we jump into the weeds?
No questions from the audience so far that many, but thank you so much for someone saying they're based in India. Hello to you there. Happy to hear from everyone else of which location they're tuning in. But I might want to ask a question from you as well. So what would you say are the benefits of running stateful applications in Kubernetes?
Yeah, sure. So basically, it's always the same thing when it comes to running things in Kubernetes. You can just leverage the basic feature and characteristics of Kubernetes, which is all about scale, being cloud agnostic, being highly available, highly distributed, which is a perfect fit for any application, including stateful application, because now I would say we have all the tools to manage those stateful application. And as an example here, I didn't mention it, but the way the MongoDB cluster is managed by manifests, which is a Kubernetes, by YAML, is by using the MongoDB operator. So now we can, with the operator framework in Kubernetes, we can encapsulate the knowledge that is required to deploy application on top of the stateful sets. So we're going to be using stateful sets because that's a stateful application, but also we need to make sure that MongoDB is properly installed with the right permission, the right database size, all of that. And this is encapsulated into a custom resource that will be managed by the MongoDB operator. Yeah.
Great. And then there is a new audience question now. So Laurentine asks, the one that you mentioned, is there a blue, green, or canary deployment?
So it won't be a blue, green, or canary deployment at this stage. What I'm going to show you today happens before this, right? If I could add canary deployment as part of it, like maybe by using Istio on top of that, but probably that's already a lot for today. That would be too much. So today is just like basically replacing the pod in production. So it's like kubectl, just replace and deleting the pod. Don't do that in production. You're absolutely right. You should not delete your existing containers, right? You should do like blue, green, or canary deployment. But yeah, for today, I'm just going to replace the front-end container. So in reality, if that was my production cluster, I would be a bad engineer because I would cause some sort of disruption.
Great.
Okay, so let's get started. So on the left here, this is my production environment. So you can see just the timestamp. I've got my the application has been deployed like 92 minutes ago. So with the MongoDB being there already, this is production. But the idea in the end, once Flux is going to pick up our changes, what we expect is this value here, right, to be like a couple of seconds, a couple of minutes, as we change our code. In the development environment, my development cluster on the right, you can see I have my application is not installed whatsoever. I have the MongoDB operator, so that when the MongoDB CRD are going to be pushed into, ingested by Kubernetes, then the MongoDB operator is going to react based on the CRD and deploy the MongoDB cluster. On the left in production, I didn't mention, but we're going to be also using some policy as code to verify that the parameters we set for our application are aligned with our compliance system. So for example, I'm going to show you a couple of rules. We want the database to be, I think, inferior or less than 10 gig. We want a special user to be created for managing the MongoDB database, things like that. And so this is why we're going to be using Kyverno or Kyverno. I'm not sure how to pronounce it. If anyone in the audience know if it's Kyverno or Kyverno, please shout out. And so we will have the admission controller there, which is set for audit. So we're not going to prevent the application from being deployed. If it's non-conformant, we're going to be generating a report. I'm also going to show you how to use the CLI as part of the pipeline if you want to also, fail the pipeline as a command line as opposed to an admission controller, like before deploying the solution in the cluster. We also have the MongoDB operator that is there to react based on the custom resource. We have Tekton that is installed as part of the cluster as well. And of course, we have the on that solution that will be leveraging the local storage to create the various PVC and also add the extra features like encryption and replication. All right, so now let's start with the application itself. So the application itself, as I said, the idea is we start with a pretty empty environment where I have my application. I've got my Python script. This is my front end. This is a Flask application. I'm not going to go too deep in the code, just explaining to you what it does. So essentially, the front end application the job is just to connect to the MongoDB cluster that is going to be deployed in Kubernetes, connect to that particular MongoDB cluster, and then get the different information I pulled from the API. And then populate the different card with it. Like all the comic books, the comic card will be populated with the JSON information I have and render into an HTML page, right? That's basically the code. It's not, it's super simple. And of course, you want to have the Docker file in the appropriate directory. So in the app directory, I have my Docker file that Scaffold will use because remember, Scaffold is going to be using Docker to build the application. So therefore, I need a simple Docker file, and I'm going to be using gUnicorn as the web server. So I've got an extra configuration for gUnicorn, the requirements, the dependency for my application, Flask that is there as well, and as an environment. And then, so this is my application. It's basically encapsulated within that folder, the app folder. I've got my code I'm going to be running into a Kubernetes job that is located into this directory, so Marvel initdb. The role of the code there is going to be to populate effectively is going to be to populate the database with the information. The role of the front-end Flask is to display it. The role of the job inside Kubernetes, the role of that code is to connect to the API, the Marvel API, and populate the database. So you will find things here like a Mongo username, MongoDB password, the replica set name inside MongoDB, the functions to get the to call the Marvel API to realize all the requests, and to store this into a results kind of dictionary, and then store that dictionary into MongoDB using the Mongo client library, and simply storing this as JSON payload into a MongoDB document. Right, so nothing too fancy there. The application, again, Python, and for this I also need to have a Docker file to be able to build that particular container. So essentially my application is two microservices, not really microservices because it's quite simple, but there are two containers that will run in Kubernetes. The first, the initDB will be run as a job, so will be run multiple times until it's successful, and the application will be run as a deployment. So I think in test we will run like 2 or 3 front end. In production we will have like maybe 4 or 5 different front end, just to address the potential load on our application. And so that is for the application. Then for Scaffold. Scaffold, again, it's super easy to configure. It's quite intuitive. If you go to the documentation, there is a couple of things I want to highlight here. So I want to build 2 artifacts, as I mentioned before. I'm just specifying a context, which is the name of the directory. So the app directory, which is where I'm going to store my Flask application. The command I need to build the container. This is a build.sh, which is there. I'm using buildx because I'm running on Mac M1, which is an ARM-based processor, CPU. So I need to use Docker buildx to build my container if I want to build, cross-platform, including x86. So this is why I'm using a custom script. Typically, if you don't use an ARM-based laptop, you won't have to use buildx, right? So this is why I'm using a custom script, which is good, right? This means that Scaffold is quite extensible. You can just specify a script that will be used to build your container. So same thing that was for the Flask. For the Marvel initDB container, same thing. I'm using the same script. Local push through, which means that I'm going to be using the local Docker socket, and push means that I'm going to push it into my Docker registry. So the only thing really you need to do at this stage is to do Docker login so that you have your credential, just cached, and then you can start using Scaffold. And then you need to specify the overlay for customize. And now if I show you the overlay, the dev overlay, this is where all the magic happen to move from a Docker container-based environment to a real Kubernetes environment where you need those different manifests. So I've got the base manifest there, which is like the naked application. And my customization, essentially, there are a couple of things. I want to provide some create some Mongo config using Customize. So Customize can dynamically generate things like secret, password, credentials, and this is exactly what I'm going to do here. So I'm going to be using Customize to create all those secrets. I'm going to also populate the different config map for the environment variable to connect to my MongoDB. I'm going to create here a number. I want to specify 3 replica for my environment, the number of pods for the front end. In terms of my database, again, this is encapsulated into my custom resource, which is now a first-class citizen in Kubernetes. As soon as I install the MongoDB operator, I can start using this custom resource, and I'm going to specify here the volume.
There's a request from the audience to make the font a bit larger so that they can see a bit better.
Larger, yeah, okay.
Yes, or zoom in and yeah.
Yeah, okay. So
perfect. And
now
then
I'm
there's
sure. Yep.
There's also an audience question, but we can figure out the font size of course first.
Okay.
Is it better now?
Yeah, you can ask him now. Yeah.
Yeah. So, yes, we got a confirmation. Thanks. It looks better. People can see it better now. So, for MongoDB, are you using Mongo? When I started my MongoDB container, when I tried to use PyMongo for GridFS, I get the timeout error for second-day databases, asks Mehdi.
Oh, okay. So timeout probably means you have to double check. I don't know, like this out of the blue. I'm not sure. But typically, the error you may face is maybe your MongoDB, your Mongo database is not up and running properly. So you want to check. Look first. Use a container that is with an image that is the Mongo client, and try to connect from before using the Python library. Try to just run the Mongo client or Mongo, how it's called, Mongo SH, the shell container image in your cluster, and from the cluster itself, try to connect to the Mongo database to check if it's working. If it's working, then you may have an issue with the way you connect to the MongoDB, depending on if it's a cluster, if it's a seed cluster. There are different ways to connect to the Mongo database. You have to check the documentation for this. But the first clue, I would say, use the Mongo SH container image and try to connect from within the Kubernetes cluster first before using the library and some code. Okay. Good. Yeah. So here, what I wanted to mention is, in terms of the storage for the database, this is where you specify the volume claim template. So the type of storage I'm going to use. So in that particular case, I'm going to be using the on_that_storage class, where I have defined all this extra feature, encryption, replication, all of that. And then I'm going to also specify the size for my data volume and the size for my logs volume, right? And of course, the storage class here, this is development, my local cluster for development. So maybe replicas, I don't need them. So I don't want to enable encryption if it's local on my local cluster on my laptop, and I don't want to have any replicas. Now I can stop. You can also, the only thing you need to change if you want to enable a particular feature is just go there, change it, and that's it, and save, right? Scaffold will take care of the rest when you redeploy your application. So with Scaffold, there's a multiple mode where you can run. So let's go back to the Scaffold part, which is there. So you can use a Scaffold build, which is going to be building your images. You can use Scaffold run, which is going to run and deploy the different manifest and build the image in your cluster. Or you can use Scaffold in dev mode, which is probably the best mode. I mean, the main mode where you should use Scaffold. So the idea is that one, right? So we're going to check what's happening from there. So it's going to be building the images. And as you can see, a new namespace is now created here. It's going to start deploying my application. 7 seconds, you can see on the top right hand here. You can see that a job has started. The job will probably fail because you can see the MongoDB, it's a 3-node cluster. So it won't be ready before like a couple of seconds/minutes. So the job will have to run multiple times, but it doesn't matter. In Kubernetes, a job will be run until it succeeds, right? Well, at least I think by default it's 10 times or until it succeeds. And the front end is already deployed, so that's fine. It's just our Flask application. But now, if we go back to Scaffold, the interesting part is that now it's also displaying the logs live of your container. So the two containers, the initDB and the Flask front end, the container logs are displayed here in what you see on the screen here is the container logs. Now, on top of that, I can start also changing my code. And because it's located into a directory that I'm monitoring, if I modify the code there and I just hit the save button, the entire application that is related to these changes is going to be, or the container are going to be redeployed. So in that case, I'm going to modify the the page.html, and then we're going to be changing that code and reflect the code in the HTML page live. So here you can see that the job is trying to add data into the MongoDB, but because the MongoDB cluster has not been deployed yet, it cannot succeed, right? So if we can see now, the job must have failed once. You can see error. So now we have the second instance of the job that will be running. But now you can see my cluster, my MongoDB cluster is up and running. So this particular job should succeed. We're gonna wait. Yes. So now you see it's downloading, or it's like kind of doing all these GET requests from the Marvel APIs and storing it into the database. So now once it's finished, we're gonna just test the application if it's working. Okay. So now it's done. What we can do now is just do a kubectl port forward for my application, which is running on port 8080. And go back to our local host 8080. So now this is my development cluster, my development application. Now let's say I want to change some of the code. I want like to use a different syntax for comic. I don't want to use comic, but I want to replace using comics everywhere, right? So I'm finding all the instances in my code to replace with comics. I'm going to just kill here my port forward. I'm going to go back here. And so the logs, so you can see here, this is representing the connection I've just initiated from my browser. So now let's save. So what I'm expecting is the container to be rebuilt and redeployed in the cluster. So before that, just to prove that I'm not lying, let's check. The front end is like let's say 3:40. It's going to be like 4 minutes, something like this. Now I save. So as I hit save, you can see I just hit Command S, right? So it's monitoring my environment, and now the container are being built and again deployed into the cluster. So now I should see again, if I go there, you can see like 12 seconds. This is my new deployment that has been deployed live in my development cluster. So again, we're going to try to port forward, and I should see here the new code that is deployed, right? So I've got the right syntax, right? So that gives you an idea of at least the capability for local development. So, and if you stop testing everything, what you can do then is you just go back to your Scaffold dev process, hit Control-C, and by doing so, it's going to delete your application, right? And you're going to see here the dev namespace is being terminated, right? Now, if you want to, I still have PVCs, so you may want to also have a script to delete PVCs and stuff like this that has been provisioned by the operator, not by Scaffold. So now I'm back again into a clean development environment. So now that I have done my changes into my dev environment, I want to use my production environment to deploy this application. So again, there are two components for this. The first component is going to be Tekton. So Tekton, as I said, we're going to be running a couple of tasks. So we're going to be using, so Tekton has a concept of pipeline, and a pipeline is composed of one or multiple tasks, and those tasks make use of resources. So I have three main tasks I want to realize. The first one, I want to build my Docker image the same way Scaffold did it. So in that particular case, I'm using a container, which is Kaniko, and I'm running a couple of commands, which is to build the image, I'm using Kaniko executor, and then I'm just using the Docker file, the path to Docker file I specified somewhere else when defining the variables for Tekton to use, the destination, the digest file, all of that. This is going to be used by Tekton to produce my image. once I've got this image that has been deployed into the Docker registry, what I want to do is also use customize to replace into my manifest, to generate my manifest with a new image, right? The new image that has been set by my previous task, which was building the container using Canico. So the job of my customize task is going to be to use customize to edit the image within the particular manifests, and then to generate those manifests into a special directory. And that directory then, I'm going to be using a workspace within Tekton, which is basically a PVC. It's just like a directory as part I'm mounting inside the container that is going to run that particular task. And once I've got the manifest that have been stored into that particular directory, what I want to do is use Git to update, to commit and push the new manifest onto my repository. But here you can see that I don't have any Git CLI task, for the simple reason, and this is why I really love Tekton as well. If you go to Tekton Hub, there are predefined tasks. And if you look for Git CLI, there is some documentation, and you can just create a task. You just name it git-cli, and the only thing you have to do is create a variable called git script, and then specify your git action, not action, your git commands to into that particular variable. So if we go back to here as part of the git script, this is what I'm doing, right? So remember, I've got locally the manifest that are that have been created by the previous task. So now I'm doing git init within that particular directory. I'm adding the origin, which is where I want to upload my manifest. I'm doing just cd target, which is where where I have my manifest. Add it, commit, push, and then the upstream repository will be updated with my manifests. And then finally, what's going to happen is once Tekton, this is the last part of the Tekton task, right? Once Tekton is going to be deploying, creating those manifests up and push it upstream into the repository, we will have not customized. We will have Flux get customization. Flux is going to pick up that particular repository that I have defined as part of the prod customization. So it's going to monitor this customization using the special source -a. It's a Git source. Sorry about this. So this is get CRDs. Sort. So you can see here, I've got from a Flux perspective, you can see I should have like sources. What cluster is this? Flux pipelines. Yeah, you can see customization there, and I should have Git repositories as well, right? So I've defined these Git repositories with the manifest as part of the repository that Flux needs to monitor. So as soon as you will see Tekton updating the upstream repo, we will have Flux is going to pick it up, right? So what we're going to do there, we're going to do a Flux get customization -w to check, like, once it's going to pick up the manifest that have been updated, monitor the changes, I should see new line there, right? So now what we're going to do, we're going to be triggering the pipeline, right? So now I've shown you this particular pipeline, what it's going to do. Again, because it's a Kubernetes-native solution, I can use kubectl to trigger my pipeline, right? So for this, I'm going to create an object based on the Marvel app run manifest. So this is the one that contain, all the different tasks, the high-level ones. And this Marvel app run will make use of the subsequent pipeline Marvel app, the different tasks, etc., etc. So let's trigger this. And again, so create this. So it's created. Now Tekton gives you the ability to monitor live what's happening. So again, so the first part is building the container. So this is using Canico. Second step, we're going to be using Customize to generate the manifest. And third step, we're going to be using the Git image, the Git task, sorry, the Git CLI task to push the manifest into the remote Git repository. And finally, Flux is going to pick up those manifests. And the last step really is, I wanted to show you when it's deploying at the same time, I'm going to have Kyverno that is going to be monitoring the different objects that are going to be pushed into the cluster. And Kyverno, this is also a Kubernetes-native policy engine. So meaning that I can specify my policy as YAML, excuse me, as opposed to, for example, OPA, Gatekeeper, because basically it makes use of Rego. Rego is a different language. For sure, it's going to be probably more flexible, but here for more like Kubernetes policies, more simple way to build policy, then you can use just YAML and create your own rules. So a couple of examples here. Here I've got a rule that says that I need to have an admin at least with all those permissions. So it is monitoring the MongoDB community custom resource. So you specify the kind of resource you want to modify to apply the rule, and then you can type the message if it failed, and then you specify the pattern. For my encryption, for example, when you're in production, you want to have encryption enabled for your storage class. If the provider like on that is providing this feature, you may want to have the pattern, I need to see encryption set to true in my storage class. Same thing for replicas. You need to have at least 2 replica where you're deploying into production. And the maximum size is 10 gig for my database in production. Right, so it's going to be giving you this results. So just here, this one. See all these report. So get cluster report, policy report. Right, you can see policy report. So we have here 2 paths, right? And we also have cluster policy report. Some of the policy I've used, I've got 4 policies, 2 are considered cluster, 2 are considered policy report. So I've got 2 paths for the cluster policy and 2 paths for the policies. And now I can also do this dash YAML. So it's going to tell you which one has passed, and if there was one fail, it's going to tell you why it failed, why it has failed. And just to give you an example of something that is non-conformant, so here if I check out non-conformant, I believe, okay, you can use, so the result I had previously, I've shown you the report, it's inside the cluster because I'm using Kyverno within the cluster as an admission controller. So now you can also, you can choose to stop and fail your pipeline if the manifests are not matching those requirements. So for this, you can use also Kyverno as a command line, right? So for example, here, I'm using Customize to generate the manifest. So it's going to output the manifest with my non-conformant, sorry, it's not non-conformant, /prod. You can see here it's prod, but it's the non-conformant manifest that are located there. So, and then I pipe the manifest, so the text file, into Kyverno, and then I just going to display the result on the screen. Oops. What did I do wrong? What policy? Okay, it's prod. Oh, sorry, maybe this one. Yeah. So you can see here in my non-conformant where on purpose I've created a size bigger than 10 gig. I've disabled encryption. All of that, you can see that I've got 3 fail, 1 pass, and it's going to tell you why it has failed. So as a result, you can choose to fail the pipeline if you want, right? So this is the last part I wanted to show you in terms of, also adding some policy as code element to it. So now just quickly get back to our pipeline. So the Tekton pipeline has finished. Now what I want to see is, you can see here now I've got another instance of the reconciliation of Flux. So Flux has picked up the new manifests upstream on my remote Git repository. So now, as a result, I should see, 4 minutes. This is when Flux picked it up, and as a result, I should also see now. Let me check if I have on the just want to check that So I have removed terminated the port redirection there. Let's go back to Tekton and then use a kubectl port forward from there. So now this is running. This is my production environment that I want to test. So let's go back to localhost, and hopefully, so you can see I've picked up my image with the change, and I've updated my production environment with it. Right, so I am now in a production environment where my application is running, but I have encryption enabled, replication enabled. I've got more container as a front end, the only difference is, as was mentioned previously, I didn't do a canary deployment. I just replaced the container using Flux, basically updating the application. Okay, so I think I'm done for the demo. Is there any remaining questions at all?
Great demo, by the way. Thank you so much. While we wait for the audience questions, hopefully come in. So essentially now is the time for you to ask the questions. Well, you could have asked them throughout the whole webinar as well, but now is your time to shine, audience. So let's get those questions in. And then there's the first one here. Where can I get this example on GitHub?
Okay, we can post it. I can give you the link, and then you can post it from the where is it located, like on the web page, or where we put all the information related to that talk. I'll make sure to post all the different links to the repositories there.
Great, perfect. And then Carlos continued, I like the Marvel app. Yes, it was a really nice demo. I agree with Carlos there. But yeah, keep the questions coming in. We have about 7 minutes for questions, so there's plenty of time, so type away. But while we wait for the typing to start, I have a few questions as well. So there are a lot of moving parts with the CI/CD pipelines. How do you select the right tools?
Yeah, so I would say basically to find the right tools, you don't have to automate everything. So I would say, depending on your use case and how you want to improve your current processes, you can focus on some of the area I've mentioned today. So maybe it's just for you want to be more agile when it comes to your own application testing on your local laptop, then you can pick up Scaffold or try other tools that have the same kind of qualities to deploy on your laptop. If you're more focused into automating deployment in production or staging, then maybe focus more on Tekton. I love Tekton because, as I said, there is this market, the Tekton hub, which allows you in 5 minutes just to use a container and do the task you need to do. And so if you want to automate is really related to your production, then maybe focus on Tekton. If what you want to enhance is maybe provide more security, more compliance, then focus on the policy as code one at a time. Use those building blocks, in isolated fashion, And once you're happy with them, then you can start combining them together. I mean, this demo took me I didn't build at once. I started by doing the laptop, then I did Tekton, then I did some things around policy as code, and then I started to add them together, right? But don't try to do probably everything at once. That would be my advice. Yeah.
Makes a lot of sense. So there was a few, there's a lot of questions now. So let's get through them. So Carlos continued, what page? So which page you will add the GitHub example to?
So what page? I don't know. I don't know. Is it like, how can we communicate this to the attendees? What would you recommend?
Yeah,
I can do
if
whatever.
you have a page you can share right now, you can post to the private chat that we have here in the production site, and then we can send it to the attendees via chat. Or you can, if you don't have it ready right now, we have a Slack channel where you can send it there as well, like later on.
Yeah, so there's multiple solutions. So I'm going to link into the chat here my GitHub repository, where this is where you will find all the repos I've used today with the name. So if you watch the video on demand and you can pick up the name of the different repository, this is where you will find all the code. And if you want to connect on Slack, you can also connect on the on that Slack, which is, I have to make sure that I'm not mistaken, on that .slack. Yeah, so if you go on our Slack channel, which is, I'm going to just post it into here. You can join this on that .slack.com channel, where you can find me if you want. I will make sure to post the links there. If you want to talk to me, you can also find me on the CNCF Slack channel. I'm there. So my name again is Nicholas Vermandy. If you want to reach out to me there, if you have any other questions, I think that should be good.
Yeah, that's good. And then we have 3 or 4 or 5 questions to go through in 3 minutes. So let's be quick but perfect. We have the next step resources ready. So a question: Tekton is an alternative CI/CD technology, correct? Being cloud native to Kubernetes. Thanks beforehand, asks.
It is. Tekton is a CI/CD solution. What is specific to Tekton is that, as opposed to GitHub Actions or Circle CI or anything else, it is running itself inside Kubernetes. So every action you do in Tekton is a container, right? That's the only difference, but it is effectively a CI/CD solution.
Perfect. So do you recommend to take the CI/CD pipeline images used in the task to copy the images, scan them, and host them yourself?
Yeah, the best thing is just update your remote repository, right? So whether it's Docker Hub or on GitHub repository for your to store your images there, do that. I guess it's better. If it's on your laptop, you can use like your local deploy your local images there as well. But I guess it's better just to update your images on a public repo somewhere, right? Public registry, sorry.
Great. And then Ravi asked, what would you change to make this demo multi-cluster? Is it just adding additional clusters in Flux? And does it happen asynchronously?
Yeah, exactly. It's multi-cluster would mean that you would have different cluster configured to listen for that particular repository where you have your manifest. So you would have maybe different overlays for different clusters. And then for every cluster, you would have Flux, or it can be Argo, whatever, that is monitoring this particular repository. Yeah, definitely, I would do this.
Perfect. And then the
asynchronously, yes, it is asynchronous, meaning that when you define Flux, you tell Flux, like the interval time it's monitoring, like every 10 minutes. Sorry, that is the default, but you can change it if you want.
Perfect. And then with 1 minute left, or a bit less, last question of today. There's a question. I always having difficulty to set the graceful exit for stateful application, mostly for DBMS type. How would you suggest for killing the stateful pod?
To kill a stateful pod, but normally if you use an operator, and if in the normally you can scale down to 0, right? If you want to delete the pod, you can scale to 0. This is the best way to delete your pod, right? Don't delete manually. Use just like if you trigger the operator to delete the stateful set, then you make sure that it's properly done. Yeah.
Perfect. That was it for today. We are right on time with the 1 hour mark. So thank you everyone for joining the latest episode of Cloud Native Live. It was great to have a session about Kubernetes native pipelines for stateful applications. And thank you for such a great speaker as well. We also really loved the interaction and questions from the audience. And as always, we bring you the latest Cloud Native code every Wednesday. So next week, we will have another great session coming up. So thanks for joining today and see you next week.
Thank you. Bye.